hello everybody. Thanks for coming. And just before to start, I'd like to make a short survey here. For those who are using Java, I will count Java versions, and please raise your right hand if you're using that Java particular version in production, and left hand if you're using it for your internal purposes, playing, whatever. Let's starting from 13, 12, 11, 10. I need a survey. 9, 8, 7, 6, 5. Okay, 14. 1.4.8 or .2, I already forgot. Okay, who wasn't attending keynote today? Because I just want to start with the demo, which I prepared to explain that activity. It's my laptop, and it's two almost identical programs showing for us Mandelbrot set. Each frame is counted on each step here. And left side is how we are doing that, particularly with old Java way, having a complex numbers as separate class. And the other version, which works faster, and you could see difference in frame per seconds, it's the same code, but that code is a little bit larger. That code larger by 7 characters. It's a word inline and 1 space. Okay, let's back to the demo and talk what is inline value types and what we did it. My name is Sergey Koksenko. I am Java performance engineer at Oracle, and my goal, my task, my job, it's making Java fast, whatever it means. Okay, what is Valhalla? Valhalla is a general name for a very large project which divided into several sub-projects. But the key goals of Project Valhalla is to provide a new value inline classes which provides better memory layout, more dense data location. The other part of that project is to make a generic specialization, which could be very useful for, you could see later why, and provide a library migration, which we have in GDK for all of that stuff. It's a large project. It started several years ago, and it's far away from finishing, and just it's our current status. So we passed 3 major milestones, which help us to understand what we have to do with the value inline classes, and we have several milestones before until all work will be done. Just a little bit about terminology. What we are going to make initially in design, it was called a value class in comparison with old plain Java reference class. But a little bit later, people started to update the Java specification. They found that word value, you can find word value in the Java specification many times. I did counting in Java language specification. It's you can find word value more than 1,000 times, and in Java virtual machine specification also 800 times. That is why it was decided to change the name of that entity which we are creating. It was some surveys, voting, and right now it's called inline classes. Such renaming was done not so ago, so I will still have a mess in my mind between value and line times, consider that words as synonyms. Okay, the key idea which we want to make is to get rid of object identity. Object identity, which every Java object creates a lot of issues related to our stuff. And as you can see, I found that even in philosophy, identity creates a lot of problems too. So because of every object in Java has an identity. It could be allocated on heap. It should be allocated on heap. We have a null value which can be assigned to that. We have mutability of that classes. We can compare instances classes. We could distinguish two objects even our method equals says that they're equal, and etc. 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 It's not my goal to do a lot of details about semantics of inline classes here. I just want to concentrate only on performance and on results related to performance which we got. So the first question which people frequently asking, if every object in Java has an identity, why a virtual machine can't understand that identity is not required at that moment and can't eliminate it for us? We don't want to do anything. Really, JVM can. I did a short search through ICM libraries of scientific papers related to, for example, for escape analysis in Java, it showed me 8,000 articles. For synchronization eliminations, also something around 8,000 articles. For Java stack allocation, also near 8,000 articles. Probably it's the same articles. I don't know. Maybe it's different articles, but at least for 24 years of Java existence, we've got 300 articles per year related to how to eliminate that or these aspects of identity in an object and to do some optimizations. So that is why finally we decided not to invent or imagine something magically which will remove it. Let's ask developers. Let developers help us to show the entities, the classes which don't have identity from the beginning. And that will allow us as JVM engineers to do a full bunch of optimizations related here. So what is an inline class? First of all, it's a class. It's almost the class as all other classes, but it has no identity. We'll check details later. It's an immutable class because of mutability required memory allocation. Memory allocation assume identity otherwise. That class not nullable, you can do synchronization over that class. And the code is quite simple. You write everything as before, you just add a new keyword inline with some kind of limitation. Every inline class is final. All fields of that class is final. Inline class extends objects and only objects. You can't make a strong class inheritance hierarchy. But the key things are inline class may implement interfaces. Whatever you want, how many you want, what else. So, and another quite important issue related to inline classes, what to do with comparison operation, equals. Expert group, expert committee considered 3 options at that moment. Deny that operation at all. Just let me finish. Do the other options like that comparison always false, and the third option is it's so-called substitutability check, when we have 2 inline classes and compare all fields recursively if it's required. So.
The class is final, but you can implement method, meaning that you can add default methods to it, or the implemented interface.
Default methods are static. Static method is just a static method, whatever, of course. And for all other methods, class will have in here. And back to reference comparison, as you see, we can't say that this inline class is equals to other. We consider different options. Right now we choose that one. Maybe in the future we finally found that it's not a good choice and come back to always false or whatever. Current status is here. And inline really doesn't mean it's inline immediately. It means its class is inlineable. JVM will decide it, will it class allocated on a heap or put it on a stack of your method, local parameters, flatten inside array. There is separate notion which called internally flattened array when we have array of inline classes and we don't have indirection from that class to some kind of heap location. And two most important assumptions about inline class were done, the two most design decisions. First of all, every inline class is assignable to object, and also it's assignable to interfaces which that inline class is implementing. It's quite important to provide all huge set of existing Java libraries to make them working with new inline classes. Because if we don't make that, it means we'll create inline classes, they're not assignable to objects, and we have to duplicate all libraries for it, all suitable stuff. It's definitely required, but it has some consequences. And the same for arrays. Arrays of inline classes are covariant with objects array. And here I want to say that sometimes it's required to do some limitation with inline class, to make weak limitation. Like for objects, we may assign null to it. For inline class, we can't. So there is a boxing operations. It is not designed a proper name for that operations. We call it boxing internally yet, which allows to make another class, another set of values which correlated with our inline type, but it's nullable. It's like a boxing. It will be allocated in a heap somewhere. But there is a little bit difference between how boxing works right now in Java and how it is working in inline classes. Like, because of int type, primitive type, int doesn't have any kind of identity, of course. It's primitive. Same as goal as for inline type classes. But if you do boxing, you'll get all identity stuff which exists in Java. You could make synchronization on Java integer, lucky for you if it works, and whatever. For inline classes, even if you wrote that as kind of type name and question mark and made a nullable copy, it doesn't assume that that type set will receive identity. Just only value null added to the set of values. People don't like usually that syntax, and probably next version it will be changed. I won't give a promise. I'm show you a current status how it's working right now. Okay, let's check. We promise that inline classes, value classes, they will work. They will have primitive as performance types. Let's do it. Let's check it. Just simple comparison. A local variable. It's a code from that demo which I've shown you. Managable set. It's complex numbers, complex computation. Usage of that looks the same. I just have to go my complex number and change from typical ordinary class to inline class. And that is performance. I'm showing it a time, and I compare reference, primitive version which is done manually with primitive values, and inline class. Inline class have a very perfect performance with primitives at its heap allocation. You don't have any kind of heap allocation in that loop. The most interesting thing which I found that we not only have much less cache misses, data allocations, but inline version has a much better scalability. It's exactly the same demo as I show you. It was 500 by 500 image zooming into multiple set, and I'm scaling it to a large machine by amount of cores. And reference class started from 22 frames per second on that server machine and finished at 97. And inline class started from 32 frames per second and finish almost 1,600. Very, very nice and better scalability which we get. Doing nothing, just add one keyword to our class. It was about local variables. Let's check method parameters. I like that function. It's almost Ackermann function, very recursive. I did a lot of recursion, measured it, and normalized measurement per one invocation. It's a cost of one invocation for that function. 10 nanoseconds for reference and 5 for primitive inline class. It works. It works. Moreover, people don't like Java. They don't like idea how I could return a multiple values from a Java method if I need. But I don't want to create an object. And always, it was ideological question. Some people split it, some put into array, other created a class. Right now, you don't have any issues to return multiple amount of values wrapped into one inline class. Array access. On one side, as we have arrays right now, we have array of reference, which point to some class. We have, from the other side, we have inline class, flattened array, when all our structures incorporated inside an array. And it's random access to that array. It significantly depends of how many data we are processing because of our cache sizes. And inline classes is much faster. It's for random access, and what if we have sequential access? In that case, hardware prefetcher may help us, and they really helps, but anyway, we have a difference with that. As I told you before, we have two things. Inline class is assignable to object in the interface. And array of inline class, even flattened array, is assignable to array of objects. Unfortunately, it means that in all places in your program, if you are working with object, and if you are working with object array, you have to check if it inline class or not at runtime. You have to do some runtime check. And the large question for us, it was to understand how big that cost of checking value classes for legacy program which don't use inline classes at all. But okay, we did a lot of stuff in that area, but also something should be done. Okay, reference comparison. It's the key thing for inline classes and for discussion, for design. What we have to do before? Before that, we have just to compare two references. Right now, we have to check if it's inline class or not. This is a code on a Java level. And here is its assembly, how it was before Project Valhalla. Pretty simple. Even people who don't know assembly probably can understand it. That is how it looks right now in Valhalla. And it's not all. You see on the left corner, it's invoke dynamic. We are touching substitutability check by invoke dynamic instruction. It means that a huge bunch of code is hidden beneath that invoke dynamic. And a little bit differentiation. If you don't have values in inline classes, you can't enter into value vault. But anyway, even reference vault became a little bit more complicated. I just admit that measuring such kind of effects is a very, very bad task. Because for modern hardware, which constantly out of order, a lot of instruction on the fly, you can't isolate effect of such code modifications and measure it's only one loop on one example, etc. It's very, very, very different, very depending on hardware. You have to do a lot of measurements, etc. So, first of all, what we got here, we got complex code, loads, and the other things which we realize that right now, currently, invoke dynamic is prohibiting loop unrolling. So, it's again another things which impact our hardware and how to measure. So here's data I took baseline code before Valhalla, measured it in unrolled and non-unrolled case. I took Valhalla and the same code, no inline types, just reference comparison. I have to use different % of equal elements just because of, again, hardware predicted differently and to get the whole picture. And Okay, I see that it is possible to get at least a 2 times slowdown for reference comparisons on some examples. But from the other side, on the other examples, everything is fine, and we know how to improve it, how to get a better performance in that situation will work. It's just a current status. Okay, let's check other affected basic operation. Loading data from object array. Again, before that in Java, even 13, it's quite simple, just load data. In case of Valhalla, we have to do different additional runtime checks. Storing to objects, the same, we got additional runtime checks. I don't have a nice picture here. It's very different behavior on different microbenchmarks from -2 till -10% performance regressions. But that regressions is visible only on microbenchmark, which I wrote specifically to pinpoint that behavior. And a large application I will tell a little bit later. And we know a set of solutions which could be done here. We are working on it. And the other operations which are significantly affected by our values is synchronization. We are prohibiting any kind of synchronization on inline classes. We have to throw exception. And just check it. It's quite simple. Difference is very, very small, and it's the only old operation which we don't care about already right now. All other will be tuned. And I want to show another example which also may affect application right now, or maybe we will it in the future, but it doesn't relate it to all that runtime checks which I shown. That a code. I'm invoking arrays equals for 2 arrays. That's arrays of integer. It's not an objects array. It's array of integer, and we know that it's array of integer. It does not contain. It can contain inline class inside, in free situation. To get some measurable comparison, that arrays are differ only by last element, just to run it. And here is the performance. 600 nanosecond in legacy world and 900 nanosecond in Valhalla world. Bad or good? Okay. A little bit checking. I found that array equals before and right now it's fully inlined. And in case of Valhalla, it's not inlined. It's not inlined just because of that reference comparison and all that involved dynamic stuff which I've shown you on previous example. The code generated for our method became larger. And the size of generated code generated budget is used by our inline heuristics. Maybe it's not a good idea. We are thinking how to fix our inline heuristic right now, but if you are going to check your application right now with Valhalla, you may meet some cases and situations. Anyway, we did a large exploration of current status. We check all our large benchmarks which we have and may use. We didn't find any serious performance degradation. These max available much observed 2%, which we saw it's maybe just run-to-run cheating. We don't know yet. We are checking that. We checked all our huge microbenchmark database which we're creating for years for Java. And it's right now in open source if you want to check it. The major amount of our existing microbenchmark are fine, other fixed, and a little bit regression also you want to check. Okay. That probably all that I want to tell you about collateral damage which people are getting, and it's our main and focus area for performance tuning right now. I promise you there is a place for improvement there. What can we check with, what can we do with inline times? Why we need it? Why, where they can be useful? Let's just check some examples. First of all, any kind of arithmetic types, complex, vectors, ray traces, whatever. It's just a classical multiplication, two complex matrices. 12 milliseconds, 2 milliseconds, and one interesting thing which I like with inline classes, it allows well-known cache-friendly optimizations, which doesn't work with if you have reference types. I did another example. I've got some ray trace algorithm rendering some scene, and I've got speed up doing nothing, just write inline keyword. I got speed up from 55 seconds to 30 seconds. Maybe it's not enough. Maybe something else should be done, but at least it's working. Another example. The huge goal for all project Valhalla, which it's library migration. And we have a litmus test for our library migration, which we want to provide in project Valhalla. It's to make a class Java util optional as inline class. That class already exists in Java, not for people who are using Java 7, of course, but it exists. And if we are able to provide a nice, beautiful migration for Java util optional to inline class, it's done. It's done as we want. And I did a simple example. I took a hash map. It's well-known idea that the interface for hash map is very bad, particularly in the point when method get returns null. It's not my idea to change it and return optional. It's obviously that having optional at that time, making interface for hash map, maybe it will provide a better and clear code. Just I'm able to make my own hash map, my own optional, make it optional, and make it inline class and measure. And here is performance difference when I do just 1 million get operations for 1 million hash map. Inline class definitely gives us benefits. Okay, another operation which I frequently did in my past experience. I want to create a map when I have several keys to one value. And in general, I know two typical classical way to do it. To write a composite key class and use it, and just to put a map of map when each component is that key. People, if you know clear and well-working third solution, just tell me, wrote me. I'm curious. Okay, let's measure it. And again, I have hash map with 1 million elements, and I'm doing 1 million different gets from that hash map. And reference composite key. It's the most clear code from my point of view. It's much more clear than map of map, but it's slower. Sometimes people don't like it. Anyway, inline composite key, almost 2 times, not 2 times, but significantly faster than composite key, but it preserves all kinds of clearness and suitability to write clear code. Another example, experience which I do in playing with hash map and to do better internal Java util structures. Not particular hash map. Hash map is just an example. You have a collection, Java utils, different set of collections. They have internal structures. If we will move it into inline classes to get benefits from better, more close data allocation, everybody will win from it, even if you're not going to use inline classes. And the most straightforward idea to work with hash map has an entries, and it's a chain of buckets. When we have key, value, some internal auxiliary information, etc. If hash map is fine, you don't have the chain of bucket. You have only one element bucket, but it doesn't matter. What if that the first element inside a bucket will put into flattened array and measure it? We did that experiments. Results are a little bit controversial. Anyway, we got a speed up on get operation. Unfortunately, we got a slow down on a put operation. And we are still thinking, we are continuing experiments. At least we can improve our immutable maps with inline classes inside, and they will be faster. And another example, also under consideration inside Valhalla team. Here is a just a map, whatever, collection. And I want to iterate through my collection and do something with each element. It's quite a simple benchmark. Unfortunately, the results for that benchmark is not stable. Not stable for that, but in different cases, I know how to make a huge performance difference for that iteration. Could you guess why? Numbers are here. What's the difference between lucky and unlucky case? Okay, first of all, it's not for all, it's iterator. And when we do scalar replacement, escape analysis did scalar replacement for our iterator, we got a benefits, very large benefits. And if our iterator was allocated on a heap, we got a huge slowdown. Even for map and for 1 million size of iteration. We put 24 bytes, it's a size of iterator class, into heap, it got almost 2 times slowdown. It definitely doesn't mean that we got a huge GC pressure just allocated that elements. The problem a little bit different, just look on the inside hash map. And it's a code shown from hash map iterator. We are on each step, we are update a state of our iterator. And that state assume writing. And if that state contains a reference field, we have to write into that reference field some new value which we count on each next step. It means we got GC write barriers. And it costs. And if object scalarized, it's allocated on stack, or all fields of that object allocated on stack, we don't need to invoke GC write barriers. And we don't have overhead. It's explained that difference, 32 milliseconds and 55 milliseconds. So the obvious idea for us is to provide better control of heap allocation with inline classes. Inline class don't need to be allocated on heap. It will be allocated on registers inside our method. And we won't have GC write barriers there. But we can't make iterator as an inline class. Iterator has a state, and its state is changing, but inline class is immutable. So we are thinking about new class, cursor, it's obviously. Cursor just point for one element. And it can be changed, it can be modified, you can do nothing with that cursor anymore. But you may get cursor to the next element. And here's example of iteration using that class cursor. Fine. We got the same and fine performance as we were getting in lucky case of iterator, but in a huge difference, it's controlled by us. We shouldn't rely on escape analysis, which not always works perfectly as before, and its performance. And probably the last example which I want to show you for Valhalla value types, it's about data moving. Definitely every program just do nothing, it just move one data from one place to another. It's what we are doing in program. Sometimes do permutation, sometimes something else, multiplication of data. Anyway, and it's look like the case that if we are moving reference classes, it should be moved, for example, from one array to another, much faster than we're working with inline classes. Because of its reference, it's 4 bytes or maybe 8 bytes in a lucky case, not some huge and large. I decided to use a well-known idea that what is the moving like. Let's check it on a sorting. When we perform a sort of array, we have to do a lot of movings, data inside that array, and do measure. And just explaining few future data, I did a reference sorting measurement. I did it for inline classes, and just having in mind that inline class may be quite large, it may be cost, maybe doesn't make sense to move inline class straightforward, maybe makes sense to do sort of indices of that values and just do less copying later, and compare three algorithms. Small arrays, which I feed into L1 cache. It's a reference, inline, and indexes when we sort indexes and just copy inline classes later. And on X, it's inline classes of different size. I did it till 64 byte, at least to understand the current picture and what we got at the moment. In that case, as I see, I even don't need an indexed sorted algorithm. Just if I have a few amount of data, better locality and inline classes perform faster in all situations. Let's do that our array a little bit larger than L1 cache, but feeding to L2. Situation almost the same, just in case of very large inline classes up to 64 bits. The performance became comparable. Okay, next step, larger array. Feed into L3, doesn't feed into L1 and L2. Okay, here we have some situation when reference win over inline classes. Maybe we have to do something for that in the future, but in reality, inline reference classes win only when our data doesn't fit into L2 but fit into L3, because of if you move further, our inline class again works better and have a better performance. And take something large, huge amount of memory, constant memory traffic, and again, that sorting works much faster than any kind of reference data. And that performance is provided only from inline classes which you got by dense and collocation of all data which we have. And dense locator, it's much more important for performance of your application right now than doing something else less. So, what we got here? Having inline classes, we got hardware-friendly memory layout, which definitely located, works faster, and it allows us to make much better performance for our application right now. Right now, we are almost done with inline classes. We tuning, we are seeking some minor deficiencies which we got into code generation, mostly in like working with references. Most source of that code inefficiencies which I've shown you, it's not just the idea is bad. It just, for example, C2 JIT compiler which we have a conspot, just it doesn't know how to do it because of it wasn't necessary before. We just have to add some optimizations for it. We are working on that. And the general picture on performance of inline classes is clear. The next step is generic specialization. I'll tell you about that a little bit later, not today. Thank you. Question, please. The question is, can Java lang string be inline class? First answer is why not? But every answer has a but. First of all, Java lang string is not a just simple class. It's an entity which proliferated through the whole Java ecosystem, through many Java things. So theoretically, yes, we can. And I want to say two things. First of all, in current form, you'll make Java string as an inline class, but the array of characters which you wrap inside inline class anyway will be separate object as it right now. Because of it's another idea, it's so-called fused string when we array could be attached to a struct. and it's not covered by the idea of inline classes right now. We are thinking about that, maybe our next step. The other problems which will arise if you make a string inline class is the following. If we'll make string as inline class, it will work, but half of application in the world will fail. How many Java applications rely on compare reference for Java string? Even people using internal, etc. How many Java applications do synchronization on strings? I know it's a quite bad practice, but I saw such application. All that will fail. So probably you won't do it. We can, but too dangerous.
So the answer is no.
You ask, can string be inline class? I said yes, it can. Will we do it? Probably no, because of its danger. Yes, please.
This seems quite useful for value objects. At the keynote, they also mentioned record. Can I make an inline record class and not bother making having to do getters and such?
Honestly, I don't know. Because of inline classes, the project Valhalla, records, project Amber, I don't know what's happening inside project Amber. Sorry for me. I don't see any objection to do that. Yes, please.
So these, did you call them fused structures where you have an array as part of the added on? That would seem to be enormously more valuable in practical usage than the examples that you've shown here. I mean, that would be a really big use case.
It's questionable. Really, first of all, it will be useful for performance, for hiding some implementation details, but it won't bring ability for users to do something more valuable. Could you tell me more than 10 useful Java classes which will win from fusing? I could imagine string, big integer. What else?
The domain classes all frequently have those functions. Right? So I mean, in real life, users' value objects actually really do look like that.
It's a question. It's not a technical question. We know that it should be done. We are thinking about that. It's just a question maybe of prioritization because of having inline classes which allow us also to change the generics, to provide generic reification and generic specialization. As for fusing those objects, we have to wait until so-called array.o. Have you heard about that project? Arrays.o. It's internal project's collection idea how to improve arrays to allow them to be fused also. It's called array.o. Unfortunately, just a beginning. And probably we just have to finish inline classes and start the other things. Otherwise, we will have some progress in all areas, but won't bring a final project, final solution for that.
About arrays and string, would it make sense to have some kind of specialized string of fixed and small size? We have special implementation of the list interface, for instance, for 0 object or 1 object, 2 object. It's very small lists, and I guess that there might be some optimization behind that. Do you think it could be possible to do the same kind of thing for string?
It's a nice idea, and I especially shown you our wiki and our mailing list for that project, so you could participate in all kind of discussion. And in Valhalla Dev mailing list recently, within a month, was a discussion when someone shown the examples when they made an inline class for short string for 8 maybe characters, etc. Unfortunately, I don't remember details right now, and you could find it here and check how it works right now. It's obvious idea problem.
Key maps, for instance. Use that
Keys, maps, and particularly immutable maps, it's the best idea, but maybe if you having a flattened array, it's even much better. Yes, please.
I'm just curious, like, the
box around, like what we used to do, pointer map back in C. Is that the purpose of that?
The purpose of that interface is provide immutable interface.
Right, but I guess like back in the old days when we iterate through large arrays, we were doing pointer map for optimizing speed and stuff. Is that kind of analogous to it? Is that kind of the semantic equivalent in Java world?
Just because of updating pointer also could look like as immutable operation. You are just receiving a new pointer. But like iterating through Java hash map, you can just update a pointer. It's a code inside. Iterate and the same code, the similar code moves inside. Right? You just have to hide that actions behind some interface. And it could be mutable or immutable interface with a state or stateless. Thank you.